So now, without further ado, let's get into our first session of the day. So if I could have my panel come on up, and we should have some name placards being put out. So this session is very kindly sponsored by our co-host, Johns Hopkins University's Applied Physics Laboratory. So please, please join me in welcoming our moderator, Gina DiBraccio. Dr. Gina DiBraccio is the Deputy Director of the Heliophysics Science Division at NASA's Goddard Space Flight Center. She is also Deputy Principal Investigator and Project Scientist of NASA's MAVEN mission, actively pursuing the effects of the solar wind on atmospheric escape at Mars in order to understand the planet's climate evolution. And she has a PhD in space science from the University of Michigan's College of Engineering. Welcome to our first panel.
On, good. Thank you for that great introduction. Perfect. We are very excited to get started with this panel and to kick off the symposium. So let me just give you a quick roadmap of the next hour, how this will go for you. I'll give a brief introduction to the heliophysics big year, and then you'll get to hear from the rest of the panel. They'll give little introductions about themselves and how they relate to space weather. From there, we'll go into a moderated discussion that I will lead for you with the panelists, but then we'll go to question and answer for you, the audience. So be thinking of your questions, submit them online along the way. Now, before I jump in to the heliophysics big year, I'm just going to ask our panel here to go down the line, introduce yourselves, say your name and affiliation so we know who we have.
Hello, so I am Jenny Meehan. I am the National Space Weather Program Manager for the National Weather Service at headquarters. I'm also the Executive Secretary of the White House Space Weather Subcommittee and the designated federal officer for the Space Weather Advisory Group that advises that subcommittee.
That's it? Only three?
That's it, I'm done.
Okay. I was expecting more. So I'm Tammy Dickinson. I'm a private consultant. I work for my own company called Science Matters Consulting. But I've spent 6 years in the Obama administration and helped set up a lot of the stuff that poor Jenny is now running.
And I'm Lieutenant Colonel Omar Navin, apparently the longest title there on the slide. I'm the Chief of Space Weather and Environmental EMFX in the Weather Strategic Plans and Integration Division and the Directorate of Weather at the Pentagon here in DC.
I am Osei Talat, and I'm the Director of Space Weather Observations at NOAA's Satellite Information Service.
All right, great. So let's kick it off with the heliophysics big year. Heliophysics is the study of our sun and its influence on everything. The heliophysics big year is an event where we're able to celebrate, explore, and experience our sun. So the heliophysics big year will run from October 2023 to December 2024. And during that time, we're encouraging everybody to participate in as many sun science events as possible. Now, 2 of those events are solar eclipses that will take place during the heliophysics big year. A solar eclipse happens when the sun, moon, and earth all align. And so in October of this year, 2023, in the continental US, we'll be treated to an annular eclipse. So an annular eclipse happens when the moon does not actually cover the entire sun. And so you're left with seeing what looks like a ring of fire up in the sky. Of course, using protective eye gear. You don't want to stare directly at that ring of fire. So then a total solar eclipse will occur in April of 2024. A total solar eclipse is when the moon is directly blocking the sun from your view. And so you're able to see the solar corona, that hot outer atmosphere of the sun. And if you've never seen an annular eclipse or a total solar eclipse, now is your opportunity to participate with us as part of the heliophysics big year because it's a life-changing event. And the heliophysics big year will end with Parker's closest approach to the sun. Parker will fly within 9 solar radii of the sun, traveling at record speeds of about 430,000 miles per hour. At that speed, you can go from Philadelphia down to Washington, D.C. in about 1 second's time. So it's pretty fast. And so it's a great time to be a heliophysicist. Please come and celebrate the heliophysics big year with us. And if you want more information, you can see the website right there, and you can also just Google it to find out more information. But we look forward to celebrating with you. So that's kind of the overview that we have for you for the heliophysics big year. And now what we're going to do is transition over to the panelists. They'll each take a few minutes to show some slides and introduce themselves in more depth than what you just heard. Up first is Ginny.
Okay, so I know I mentioned 3 titles, but I'm here representing one, and that is the White House Space Weather Subcommittee, and it's the Space Weather Operations Research and Mitigation Subcommittee, that is. And so I just want to talk a little bit about the SWRM structure. So it's co-chaired by the White House OSTP, Office of Science and Technology Policy, by NOAA, Assistant Administrator for Weather Services. It currently is Mary Erickson. She's the Deputy Director of the National Weather Service, but it soon will be Ken Graham, who is the new Director for the National Weather Service with Mary's retirement here in April 1. It's also co-chaired by the DHS, Assistant Director for National Risk Management Center. So it's covering a full breadth of operational agencies. The way it is structured is broken into cover the 3 objectives that the National Space Weather Strategy and Action Plan sets to achieve to prepare this nation against space weather effects. And that objective 1, to enhance the protection of national security, homeland security, and commercial assets and operations against the effects of space weather. Objective 2 is to develop and disseminate accurate and timely space weather characterization and forecasts. And objective 3 is to establish plans and procedures for responding to and recovering from space weather events. I have two of my objective leads over here, Omar and outside here. And then Tammy, as she said, did stand up SWRM several years ago, and it's been carried over across administrations. It's now mandated by law when it was signed into the PERSIF Act, which I'll talk about here in a second. Okay, so in 2014 is when the White House chartered the SWRM. Again, it coordinates all the executive branch actions to improve the understanding and prediction of space weather phenomena. As you heard from Dr. Scott Pace, how important it is to include, especially when it comes to our space flight, human and robotic, and also our satellites that fly out in space. Okay, so the SWRM is full government. So there are 34 different departments, agencies, and offices that are principal members of the SWRM. And it was spun up by the Executive Order 13744, coordinating efforts to prepare the nation for space weather events. And so we had a strategy and action plan released in 2015. It was updated in 2019. And then the PERSIF Act, which was the very first space weather legislation signed over by, President Trump, passed by Congress unanimously, then defines the roles for the federal agencies, and also stood up the Space Weather Advisory Group that Tammy will talk about here to advise the SWRM. So we get the full community approach, not just the government, because the SWRM is all federal members. Okay, so again, there's 3 objectives to achieve within the SWRM. There are a set of 88 actions to implement this across the federal government, but it is currently being updated because, as you know, technology advancements happen rapidly, and so refresh every 4 years to support that. And the advisory group, which Tammy will talk about, will be helping us update those implementation actions. Okay, so there's several SWRM priorities. R2 to R, so research to operations, and operations back to research, how we could fill that valley of death. And so make sure we get the best research possible that has operational potential down into operations. And then also to hear what the forecasters need to better their forecast and put it back out to the research community so then they can fine tune what they're doing. And then define those benchmarks. How big is big? Okay, what is important? What do we need to know? Space weather scales, so a lot of our storms are forecasted off a set of NOAA scales, just like the hurricane, category 4, that's relatable. So how do we have space weather scales, but those need to be refined because they were done back in the late 90s and a lot has changed since then. Okay, space weather hazard mapping in the United States is very important. We'd like to know exactly where, if there's going to be a space weather event, exactly where. Right now we could say earthward. So how do we refine the hazard mapping of the United States? Hey, observations, also we'll speak about that, and forecasting to support human spaceflight is really important. Space weather observations in general, and modeling to improve space traffic coordination and space situation awareness, which you heard the importance again from Dr. Scott Pace. Uh-oh. Okay, and then just a few more. How do we maintain safe operations for aviation? Response, recovery, and operation plans and procedures for space weather events across all stakeholders and sectors. And then continuity of operational satellite missions to provide the chronograph, solar wind, and genic particles, and other measurements essential to that space weather forecasting. So with that, I will pass it over to Amy.
Okay, so as I mentioned in the introductions, I'm Tammy Dickinson. I work in my own consulting company. The two most important pieces of information on this slide is my email address, in case you want to get a hold of me, and the asterisk at the bottom that says all opinions are mine and are not those of the Federal Advisory Committee. So I am here representing them, but if I make an opinion, it is mine. Good job?
Good.
Yeah, okay. The lawyer's kicking me under the table here. So I just have a couple of slides. This one is of the membership of the SWAG. So the Space Weather Advisory Committee, or the SWAG, so SWARM and SWAG are going to be thrown around here, was stood up in October of 2021. It was stood up by the NOAA administrator. It was required by the Pro-SWIFT Act, which Jenny talked about. The members were appointed by the SWARM. There are 15 members, 5 each from the non-government end user group, the commercial sector, and the academic community. Different from some advisory groups that some of you may have been, federal advisory groups involved with, we are not represented, we are not special government employees. So we do not carry the conflict of interest rules that many of the federal advisory committees do. We are expected to go back out into our communities and talk to our communities and get our communities' input back into all of our activities, hence the whole of community that Jenny mentioned that the SWAG is supposed to be representing. I'm not going to go through these people. Many of you in the room know many of them. You can go, the bios are on weather.gov/swag if you want to look anybody up. I broke it already. Which button? Ah. Yeah. Second, I'm going to run through real quickly some of the things that the SWAG is doing. So we were stood up. The Pro-SWIFT Act says that we are supposed to advise the SWARM, which Jenny mentioned. We've been working on an action to provide the SWARM with input as they update their National Strategy Action Plan and Implementation Plan that Jenny mentioned. We had a meeting in January, an in-person meeting where we got community and public input for the document that we are currently writing, literally as we speak, for that. We're required by the Pro-SWIFT Act to do what's called a user needs survey. So we're supposed to be looking into the communities and doing a survey to figure out what various sectors of the space weather community need. We have divided that into 10 sectors: aviation, power grid, human spaceflight, emergency managers, space situational awareness, GNSS, and research. Those are the 7 we are working on right now. We are in what's called the Paperwork Reduction Act process, which you would think would reduce paperwork, but actually doesn't. But it's required that we do this for OMB to approve that we can go out and talk to more than 10 people. So we're in that paperwork process. We have the surveys all ready to go. At the Space Weather Week, which is in the 3rd week in April in Boulder, we do hope to be able to do some focus groups of these surveys for some of the people that are at the Space Weather Week. So that's our hope there. Other tasks that Pro-SWIFT lays out for us to do is to advance the space weather enterprise, to improve, to prepare for, mitigate, respond to, and recover from space weather phenomena, and to enable the coordination of R202R. And we will be working on all of those as we move forward after we get our report done on the implementation plan and start our surveys. So we've had 3 meetings. We have had 4 meetings. We had 3 meetings virtually and 1 hybrid, and we have an upcoming meeting on March 20th that will be virtual, and you're all welcome to attend. You can go to weather.gov/swag to get the information. You do have to pre-register. No fees or anything. We just need to be able to send you the link when it gets ready. So With that, I will pass it on. Good luck with the.
There we go. All right, I'm again Lieutenant Colonel Omar Nava. My official duty is I serve as the lead for space, weather, environment issues within the Department of Defense, federal agencies, and international partners. So I'm really happy to be here. Thanks again for the invite. Basically, I'm just spending the afternoon hanging out with my colleagues, and I think this is sort of my first in-person panel, at least for me. So excited to be here. And similar to Tammy, disclaimer here: views expressed in my presentation are my own personal views and not necessarily the views of the Department of Defense or the Department of the Air Force. All right, so basically here from a national security lens, in October 2022, the White House published the latest national security strategy. And of course, we all know that people around the world depend on space for their prosperity, and outlines in the document that America will maintain its position as the world's leader in space, and work alongside the international community, sort of the collaboration aspect again to ensure the domain's sustainability, safety, stability, and then of course primarily focused on the security aspect there. And so taking the second statement with the lens of the space environment, really trying to enhance the resilience of U.S. space systems, basically with the aim to protect U.S. interests in space. So basically, mitigation of space weather events is going to play a huge role in that. And so then drilling down to the Department of Defense side, also in October 2022, the Department of Defense published its own national defense strategy, and the department's priorities are listed there if you sort of just focus on the verbs, defend, deter, deter again, prepare, and then the bottom line here, most applicable to this session, build a resilient joint force. And two aspects in the document that sort of give guidance on how to do that. One is cultivating talents. And so, building a workforce that has the skills, abilities, and diversity to be able to, solve the national security challenges. So the people aspect. And then the second one is modernizing systems and making sure, we have access to the latest and greatest to do what we need to do. So people and systems, when integrated together, then translate to joint force capabilities. And I think, as Jenny mentioned, space situational awareness is one of those. And so, as I mentioned, a common theme, the National Defense Strategy also mentions that we can't meet these complex and interconnected challenges alone. And we do rely on mutually beneficial alliances and partnerships, and of course, especially interagency partnerships. And one of those aspects is the swarm as well. So, bottom line, we know that space is integral to military operations, and unfortunately, this upcoming solar maximum in 2025 really doesn't help things. But key takeaway here is that Air Force Space One enterprise is constantly evolving, trying to make sure that we have the right people with the right skills, in addition to the right capabilities. All of these are integrated together to address the priorities listed in the National Security Strategy and National Defense Strategy. Thank you.
Okay, as Jenny alluded to, NOAA's responsibilities include providing operational space weather monitoring, forecasting, and long-term data archiving for civil applications. And part of that is to maintain ground-based and space-based assets that feed into these forecasts, models, and warnings. Also, NOAA provides research to support operational activities and develop requirements for space weather technology and science. And so what that brings me to what we do in my office, the Office of Space Weather Observations, where we're implementing two programs that will move us from the reliance on aging research assets and ad hoc efforts into a systematic operational capability for space weather. And the first of these, and we're implementing this as in a joint program or joint office with NASA at Goddard. And so the first of these is the Space Weather Follow-On program, which sustains NOAA's foundational set of space-based observations and continuity of critical coronal imagery data and upstream solar wind data. And we do that with, we're going to do that with we have integrated a compact coronagraph on the GOES-U spacecraft, getting ready for its 2024 launch, as well as developing an observatory with a coronagraph for coronal imagery and in situ solar wind measurements that's going to launch as a 2025 rideshare with a nice NASA IMAP launch. Thank you, Nikki. And we just started the Space Weather Next program that will maintain and extend the space weather observations from a range of different observing vantage points. And so we're planning for continuity of observations from L1 and GEO, but also adding capability in L5 and low Earth orbit, as well as developing the ground systems that will downlink the data and distribute, generate the products and distribute them. The program and the first project, the L1 series, are in formulation phase. We just completed a systems definition review after concluding an extensive analysis of alternatives, and are getting ready for our mission concept review for the L1 series. In formulating this program and the projects under it, we have extensive user outreach targeting aviation, electric grid, and satellite operating communities with our partners at the Space Weather Prediction Center and other government agencies, and looking at international domestic partnerships for extending our observational capability and support for an exchange of space weather observational data. And then obviously, as we get further along, we're developing RFIs and RFPs for the instruments and observatories that we'll be developing under these projects. Thank you.
Can you pass the clicker all the way back down? Thank you. Okay, so I'm also going to take this opportunity to just give a brief background of space weather resiliency at NASA Goddard. So at NASA, we're working to implement priorities from the heliophysics decadal surveys. The heliophysics roadmap outlines 3 overarching goals that you see right here. Now, these goals are stemming to address fundamental questions that align with both the agency objectives and the 2013 decadal survey. Now, the next decadal survey is currently under works as we speak. So you can see these 3 objectives here, but the one in purple at the bottom is what's relevant to our space weather panel. Now, it's talking about building the knowledge to forecast space weather throughout the heliosphere. So relevant to our discussions, at NASA, what we're doing is we're working to develop and build the knowledge and capabilities in order to build this space weather resiliency that we're discussing. We do this by partnering with the greater heliophysics community, internationally, across agencies, with the private industry, academia, and more. So at NASA Goddard, within the heliophysics division, our vision is to discover and innovate in heliophysics for the benefit of those on Earth and those exploring the solar system. So what that means in terms of space weather is we're trying to increase our understanding of the fundamental physics of the Sun-Earth system. And so as it's outlined in the Pro-SWIFT Act, we do this by performing basic research, providing space-based observations and modeling, developing new space-based technologies and missions, and then monitoring space weather for NASA missions. And quickly, just to give you a sense of some of the space weather activities that we have going on at Goddard, this is a list of 4 of them. There are many more if we had more time. But our Moon to Mars Space Weather Analysis Office, it provides novel capabilities to characterize the space radiation environment. It also supports NASA robotic missions by providing space weather assessments, and it serves as a proving ground and test bed for capabilities that will eventually transition over to the operational agencies. Our Community Coordinated Modeling Center, CCMC, it sits at NASA Goddard in the heliophysics division, but it's a multi-agency partnership, and it's really pushing the envelope to perform research and development for developing next generation models, including space weather models. And so CCMC has really revolutionized the way that models and the results are available to the community, not just the model developers themselves. Now, the Hermes instrument suite is a Pathfinder payload that will be on board the Gateway. At Goddard, we're providing project scientist support, and we're developing some of the instruments that will be on board as well. And the science for Hermes is to really understand local space weather as it might impact both deep space and long-term human exploration. So then finally, we have the Geospace Dynamics constellation. That's heliophysics' next flagship mission. It's going to consist of 6 polar orbiting satellites, and among other things, it will also provide real-time space weather data at unprecedented global and multi-scale coverage. So at Goddard, we're supporting the GDC mission by managing the project, providing our project scientist support, and also developing some of the instruments that will be a part of the mission. And so that kind of rounds up here what we have for our diverse panel, just to give you a sense of everyone, their background, where they sit. So thank you to our panel for those introductions. What we're going to do now is shift into the moderated discussion. So during this time, keep thinking of your questions, and we'll go from there. So for the first question, what I would like to do is I'll pose it. We'll see who wants to go first, but I'd really love to hear from all the panelists on this to kind of understand your perspectives. So bringing it back to the basics, we've talked a lot about space weather, but what is space weather? What does it mean to you from your perspective, and why should our audience care about that? So who would like to jump in and go first?
Sure.
Thanks, Elsa.
So from NOAA's perspective, NOAA's mission is to protect the nation's, the life and property of the nation. And so from our perspective, space weather is activity on the sun and near Earth space, and the conditions that those activities engender that can that affect our technological society, our satellites industry, our electric grid, the things you heard about from Jenny, also our travelers out, they go out into space as well. So that's from my perspective.
Okay. Well, I actually don't have a PhD in space physics, but from the Department of Defense's point of view, space weather, in a nutshell, is complicating. It's like when you're trying to, say, navigate through traffic in downtown DC, and then it starts raining. It doesn't help things. But from a national, okay, good, everyone's laughing. All right, from a national security perspective, really knowing the space environment and what space weather is doing is critically important. So you imagine you are driving around, same scenario, but GPS, all of a sudden stops working. And as you can imagine, the US's response to that would be drastically different if it was caused by space weather or someone else. So that's in a nutshell sort of why we care. And okay, yeah. What was the rest of the question? Was that?
Yeah.
Okay.
What does it mean to you, and why should our audience care? So I think you covered that.
Yeah, should be good.
Yeah.
All right.
So, and the point that I'd like to make too, talking about GPS, right? So you're thinking about it from a defense perspective, but of course it will affect basically everybody's life who's in this room too, from not only defense, but if you're trying to navigate here to get to the symposium. I know I was using my maps on the way here. So something to think about how your everyday life could be affected by that.
So I think back to when I started to get involved in space weather back in 2013, 14. I probably should ask if this is being recorded before I say this, but oh, it is. Okay, let me clean this up a little bit. So I was at a function, and I worked at the White House. I worked at the Office of Science and Technology Policy, and I led all the natural disaster work. And somebody came up to me at this function and said, "Hey, so-and-so is leaving, and you're going to take over space weather." And I went, "Space what? What are you talking about? What is space weather? I thought I knew all the natural disasters." Well, I knew about earthquakes and hurricanes and tornadoes and all sorts of landslides and mudslides and that volcano, everything you could think of. I'd never heard of space weather. And I was not, I think I was probably representative of many people in the country. What is it going to do? But then as I started diving into it with the help of people such as those at this table and learning more about it, it really is one of those low probability but high impact natural disasters that can really get you. Not only will it get you not being able to drive around, how many of us still own a map, a paper map that you could get out of your trunk? I threw mine away a few years ago. So you wouldn't be able to use your GPS. No, I don't want to share my password. Your electric power grid could go down. You could have long-term power outages, not just like after a hurricane or something, because it could destroy some of the transformers, which are made all one by one. They're all unique. you start diving into it and it looks really gruesome. So I think it is extremely important, even though it's a low probability event, that we take it seriously and we figure out how to mitigate and build our resiliency to it, because it's a lot cheaper than trying to recover.
Yeah, and so space weather, as you've heard, I mean, it's such a big problem, and it's not just NASA's problem, it's not just NOAA's problem, it's not just DoD's problem, it is all of our problems. And so what it means to me is getting everyone to leverage each other's strengths, coordinate, and fix the problem. Well, mitigate the problem, I guess, not fix it. It's going to happen, okay? And so how do we prepare for it and then respond to it once it does happen? And so space weather to me means just how we all work together to achieve one mission. And so that's what we're doing with the SWIRM and and getting the outside perspective. It's not just the federal government. We want to know the end user, the industry, the innovation that comes from all of you, and incorporating that into how we prepare. And how we respond to. And so that is what space weather means to me. So.
Yeah, please.
I think one of the differences between space weather and many natural disasters that we're used to is there's not a whole lot as individuals that we can do to prepare for space weather. It really has to be a national effort. Mm-hmm. Hurricanes, floods, other things, there's things that you can do personally or with your property, et cetera, to be more prepared. And that's not the case for space weather. So it really does have to be an all of government, all of community effort to prepare the nation.
I think another key difference in space weather is that if we are able to set up the system and do our jobs right, we can avert disasters. You know, that's a key here, and so that you won't see the list of space weather disasters happen to if we are able to alert and warn and mitigate and respond quick enough.
You'll never know it happened if we're good, if we're lucky.
Unless you see the aurora, like in Florida, then you'll know something's going on.
Before we move on to the next question, though, Tammy, you were making a nice connection between space weather and some of the weather or natural disasters that we have here on Earth. So can one of you kind of make the connection between forecasting weather on Earth versus what we're working to do with forecasting space weather?
I think that would be a good NOAA question. I'll stay in my swim lane.
Okay. So we've progressed very rapidly in space weather, learning from the lessons and taking the techniques from terrestrial weather, but we're still fairly early in terms of having both the data density that needs to go in to produce accurate forecasts, and also the fundamental physics for the forecast. And also the data assimilation techniques that meld those two to make the forecast more accurate. We have kind of models that go from the sun all the way down to the geomagnetically induced currents, and in each of those are providing a measure of capability and predictability, but there's still a lot of research to do, a lot of development, and a lot of observations to make, both from an operational and research side, to advance us to where we're doing this sort of large data assimilation and variational analysis that goes into numerical weather prediction, for instance.
Great, thanks. So that's actually the perfect answer to transition. Oh, do you want to say something, Amar?
Well, I was just also going to say one of the big differences is just public knowledge. I mean, with terrestrial weather, everyone knows what a tornado is, not necessarily how it forms, but they sort of know it's destructive, hurricanes as well. A lot of people sort of on a day-to-day basis honestly care more about terrestrial weather, if it's going to be cold, if it's going to be rainy. But space weather-wise, someone comes up to you and says, or you ask somebody about space weather, it's just already a sort of nebulous term to the public. And so, it's good that there's efforts like this, trying to get it out in the news and try to talk about it more, and just to inform the public and try to get to that level of just common knowledge.
That's a great point. Thank you. So let's shift over to the next question, which, this panel, we're talking about the future of space weather resiliency. And so El Sayed was just commenting on a lot of the work that has to be done. But what does space weather resiliency look like to you? when that is achieved? What would that look like to you?
Nothing happens.
think that-
As Elsa had said, so becoming resilient towards space weather, it's, the more we understand from the research side, like, understanding our star even, and being able to predict space weather, and understand all that, that region of space. There's so much happening and so much is interconnected. So taking all of that research, put it into our operational models and observe it as well. And then, being able to, withstand the major storms and not having any major impacts, and hardening our systems, right? So understanding your system vulnerabilities, not just in space, but also on the ground, especially with the grid. And then, hardening it to, whatever effects that may come from space, because we may have not seen some of the biggest space or solar storms that have happened. So just really understanding, and it takes time. I mean, the sun and the solar max and solar min, it's an 11-year cycle, right? We don't get an every year peak in, hurricanes or whatever, or with solar storms. And so it's a long process. And so just connecting all the dots and preparing and just, building to withstand is how I see it.
I think another piece of it is, even though we understand how to build a tornado-proof home or hurricane-proof home, we still have damage. So I think even that, I think that's a great goal. Another piece of it, I think, is being able to get back up and running as soon as possible, deal with whatever the damage is, whether it's to the grid or to GPS systems, whatever, get back up and get everybody back up and running as quickly as possible, being as resilient to that storm as possible. And I think to do that, I think one of the pieces that I don't think anybody's mentioned yet today is exercising, practicing. So the government runs through high-level government exercises where all the federal agencies sit down around a tabletop and they pretend like there's a hurricane coming or a space weather event coming, et cetera, et cetera. I think there's discussions now of broadening that to a whole of communities so that the emergency managers across the sections of the United States that could be impacted are also playing the game, exercising the game. And so I think some of those things are also important as we look at resiliency going forward.
Yeah, well, Tammy stole both of my answers.
Oh,
but
I'm sorry.
But they're basically I agree with both your points. You have your normal everyday. I mean, especially as we come towards solar max, there's going to be space weather, events popping off regularly. And there's an old saying in the space weather community, weathering the geomagnetic storms. And actually, I just made that up, but it should be an old saying. But the big concern is, you have these long duration missions, say, Artemis and M2M trying to get to the moon. You're not going to be really worried about that huge, society altering event. It's going to be those small events that pop off throughout the long duration of the mission. So how do you, ensure, protect against that, plan for that, and make sure, resiliency is built in. And so, you have the everyday events, you have the big events, and, when asked, what keeps me up at night, is it that huge Carrington-like event from, over a century ago, or sort of those regular day-to-day events during solar max? And really the answer is yes, it's all of the above. But, as we pointed out here, we've got a lot of people across the government, working on this, trying to address the issues, and hopefully, going to call out the fifth row probably, I don't know how many times. You should probably switch rows throughout the days to confuse people. But, I mean, you're the future here, so this is going to be something you're going to have to deal with as well, so.
So I'll bring it into more focused about the resiliency in the observing system, because as I mentioned before, we have a very fragile operational capability right now for space weather. And so when I think of resiliency, that's what we're working towards in NOAA is building up resiliency for both the forecasting inputs, the imagery and the upstream solar wind inputs, but also the measurements in geospace, the geostationary and in low Earth orbit that can feed into models and advance our predictability. So that's a key issue that we're addressing right now.
Great, thanks to all of you. Okay, so we're talking about the future. and how much work needs to be done and the fragility of the system. But let's also give credit to what has been done, right? So can we talk a little bit about maybe some of the biggest advancements that have occurred in terms of, preparing for space weather activities over the last decade? What are some of the big leaps that we've taken over that time?
I'll start on this one just so I can steal Jenny's thunder. And I'm going to stay in my policy swim lane and let you guys talk about the technologies. But I think one of the big advances happened back in 2014 when we were able at the White House to bring the science community to the same table that FEMA, DHS, FAA, DOE, et cetera. We had for years sort of the scientists all sitting around talking about space weather. I assume these guys were too, but I was not involved. And finally, we were able to get the two groups talking together. And I always told people when we made the first space weather national strategy is it didn't have to be perfect. It just had to be a document to get out there, and you could continually improve it and update it as it went on. But the two groups had to start thinking together. So I think that was one of the big pieces that sort of made us start turning a corner. And then Jenny listed a lot of the policy things that have happened since then, ending with ProSwift in 2020, which codified a lot of what's gone on by executive order into law. So in the future, no president will be able to decide that there's not a space weathered swarm and a SWAG. It's in law.
Jenny, can I put you on the spot and ask you to explain ProSwift Act to our audience?
Oh yeah, so the ProSwift Act, it essentially defines the roles of the government bodies. And then it says, okay, you need to have observations that are redundant in a sense, like continuity of observations. And then it also says the government needs to work together. And so it codified the swarm into law. And then it also said, well, then you need a whole community approach. And so you need the advisory group. And so then it laid out exactly how that's going to be structured. And then it said, okay, no, you manage it. So anyways, here we are. And then it also said, okay, we need commercial data buys. And so Elsa could probably talk about that a lot more than I can. And then also it said, okay, well, we needed a round table managed by the National Academy of Sciences. And so how do we facilitate innovation and ideas from the commercial sector to the swarm and so forth. So it essentially lays out a goal to prepare this nation for space weather events, and it lays out roles, responsibilities, how do we do it a whole community approach, and how do we get that innovation in from the private sector, and then, carry it out. So that's the ProSwift Act.
Great, thanks. All right, now who would like to keep talking about,
I guess one aspect I want to bring up, personally, well, for better or for worse, I think social media is also, people have mixed opinions about it, but I think it's an opportunity here that we can use to try to get more knowledge about space weather and its impacts. One example, I think I remember from a few years ago, Aurora Source, which I think was a NASA program, getting the public involved in trying, taking pictures of the aurora, documenting when it occurs, and really benefiting the scientific community in that aspect. And then there's also, I guess, YouTube channels. I think it's Tamitha Scove, who also is regularly out there, and people watch that. So I think, and I know there's people, that's something that we've highlighted on our radar, something that I think we need to develop more, just because more you get out in the public, it's more on people's minds, more people are aware, and fortunately we haven't seen such a huge catastrophic event, and hopefully we never will. But, if for some reason that time does come, at least people might hopefully stay a little bit calmer. But that's also another way to get that information out as well. So that's my answer. Yeah.
Okay, and then also, so Tammy mentioned the policy side. From the NOAA operational side within the National Weather Service, space weather it's one of the 11 programs that we focus on, along with fire weather, snow, or winter weather, tropical weather, and so forth. And then also we have a modeling suite that Elsa had also mentioned. So how do we model, directly off the sun all the way down to Earth and the effects, and produce alerts, watches, and warnings. And so that's something in the past 10 years that we have really worked really hard on. And it's not just NOAA. Again, we've taken models from the community. We worked really closely with NASA, and even when they stood up the Moon to Mars office as a quasi-operational entity and doing this innovative testing of models and then transition as quickly as possible over to NOAA so we can make it operational for the nation. And so we have these really beautiful relationships with our federal partners and also with the community, and getting the models and the products out there that the nation needs. And then observations that you talk about.
Yeah. And so before I do that, I'll just add to the models. Really the models we use at the Space Weather Prediction Center have all been developed basically in the last 12 or 13 years. So within the last decade, they've been brought online, ported from the community or developed internally in-house, and really in the last decade. So it's really a very quick advancement, and the same thing with our observational capability, where we're seeing a real research to operations kind of a path for the measurements that we're going to make on the Space Weather Follow-On, that we're making on Discover right now, and we're going to make in Space Weather Next program, where the technology is there because we've flown these on research missions, including to Mars, and so that enabled us to make these advancements, and so that we're able to basically just go out and procure for our operational capability. And you mentioned commercial data buy. That's another big development that's happened within the last 4 or 5 years, is having that data out there that we can add to part of our system of observations and a way to fulfill our requirements operationally. And I think it's a very exciting time from commercial sense, but from the research sense, I think Nikki would say, it's a great time to be a heliophysicist. And so the advancements are coming fast and furious, and it's very exciting to see how those are going to translate to our operational capability in the future, both in the modeling and the observational side. And then one last thing from a programmatic standpoint, NOAA, as Jenny mentioned, has space weather as a priority at the NOAA level, but within the NESDIS, it's become it's one of the 6 strategic priorities within the last 3 years, and that's why we transformed my office into the Office of Space Weather Observations to focus, and it is a focus on that as a growing priority for NOAA.
Great, thanks to all of you. Okay, so at this point, we're going to pause from the questions and open it up to the audience for some Q&A.
Whoa.
Lots of questions. Wow, this is great.
5 is
The
well
whole
represented.
Should have more
Check.
time.
They get extra credit if they
All
ask
right, so we
questions.
have some microphones coming around. Just keep your hands up, please.
And then we can go over there. Thank you so much. What a wonderful panel. I'm really glad that all these agencies are working together. One of the things, honestly, I'm curious about these high energy events. Although they're rare, one did happen during the last solar maximum in 2012. There was a dangerous active region that fortunately rotated away from the Earth before it actually exploded. So these things do happen, perhaps, during solar maximums. What happens when one of these is detected and it's coming towards the Earth? I'm curious as to what the flow of information and the flow of action is. I think that's a wonderful thing for the public to know that we have that covered.
They exercise that.
Do you want to start?
I'll take. I'm on the observation side, but I'll take a stab at it, and you guys can add to it. But we continually watch the sun, just as we watch the oceans from space to see anything forming in the Atlantic basin. We watch sunspots and see how they're the activity that's emerging. And then we have instruments in space and on the ground that look for signs of these explosions, and alert. And then, first of all, warnings are coming out when we see emerging activity, and then alerts come out when there's an explosion or signs of more serious activity on the sun. And then we have in situ measurements upstream of Earth and in geostationary orbit that capture these very high energetic particles And so we can warn industry, and we'll work with the SRAG, the Space Radiation Advisory Group at NASA, and the Moon to Mars, and other bodies that are able to warn our stakeholders, our end users, the astronauts, the satellite industry, et cetera, of these dangerous particle events. And and then there's also the forecasting that comes from the models that are at the Space Weather Prediction Center that ingest the observations at the sun, ingest and correct them as they come towards Earth, and then also forecast the particle environment in the near Earth space.
Yeah, and beautifully said. So I'll just add a little bit. So if there is an event on the sun, as you said, it depends where it is on the sun, right? So is it coming towards Earth? Okay, it looks like it's coming towards Earth. And so we don't really know what is happening in that burst of plasma until it hits our buoy out in L1. Okay, what's the structure look like, speed? Is it going, once it reconnects or connects with our own magnetic field, is that going to wreak havoc on our systems? And so it really is just getting everyone, hey, this is happening, send out our alerts, notify who it is, like our power grid company. We have a hotline, so we'll call them, say, hey, this is what we saw. We'll know a little bit more in 10 hours, depending on the speed. And so just get ready with your action plans and so forth. And so then also there's other communication plans, how we get it up to the president if need be, to notify whoever it is to take action as soon as possible, depending on severity of the storm. So yes, we do have some protocols in place, and it is a whole of government and community approach again.
Great question.
What kind of lessons have we learned from past solar weather events, and how are they being learned from and implemented today?
I'll take a stab at this one as well. I think, first of all, we've been observing the sun from the ground for centuries, for thousands of years, frankly. And during an eclipse, as we're going to have soon, we can see the activity around in the outer atmosphere of the sun, where a lot of the space weather events really originate, really become possibly impactful here at Earth. But we've been making measurements in space for only a few decades, and we've learned a lot about, for instance, the solar wind, and how these events from the sun can impact the magnetic field that protects the Earth. And we've learned about what the explosions off the sun and how to measure them with a coronagraph to simulate what a natural eclipse does. And that's been very key to our operational capability, is to understand that these large explosions off the sun can have the biggest impacts here on Earth. But we've also learned, as Omar was saying, that there's day-to-day degradation that happens to some of our technological infrastructure from continual space weather events that happen pretty much all the time. They increase intensity during solar maximum and decrease during solar minimum, but they're a continual grinder on the system. And so these are the things we're learning. But as we've mentioned, several of us have mentioned, there's still fundamental physics that we're still exploring. We cannot predict when right now yet when flares are going to happen, when these explosions are going to happen, or are at least in a very long-term predictive manner. And we're still developing the models to ingest the data that would help us predict how these events are going to be impactful on Earth, and what the impacts are going to be once it hits the sun, the Earth system here, the near Earth space.
Yeah, and also a great question is understanding, okay, so not just the big storms we care about, it's also the little storms, right? So last year, February of 22, we got a notification that SpaceX, Starlink, they suffered impacts by a G1. And we're all like, what? That's a G1? Like, what are you talking about? So it's really understanding the vulnerabilities.
Can you define G1?
Oh,
G1
yeah.
for our audience.
Sorry, yeah, geomagnetic storm. So yeah, it's on the space weather scale. So it's a low, minor storm, what we consider minor. And so really understanding, okay, well, this is a new, customer set, and they're flying in a different space. It's understanding now the system requirements and the vulnerabilities for not just the major storms, but also the minor storms. And so that's something we've learned in a previous solar event. And then understanding how we at NOAA, because of protection of life, protection of property, how do we better serve this new community coming out? And so Dr. Scott Pace again said, okay, so space situational awareness is critical. So you better know the environment you're flying in. And so how do we best help educate and prepare, that new industry coming out? So.
All right, we're going to go over here, please.
I have two questions. Oops. Okay, first one is easy.
Let's start with one. Yep.
How much is being spent today, this year, to prepare and make the system resilient against the big storms? Not those that kick out a satellite or will damage a spacecraft, because nobody's going to riot in the street if Artemis is lost. But society is going to have a problem surviving when we have no electricity, no water, no communication. And how much do you think it should be spent?
Anybody want to throw out a number? Otherwise,
I guess answer to that question, not enough, and we'll always use more.
But the good news is we are working on it. And so there have been mandates out, especially for the power grid, just to know your system vulnerabilities and have a plan to deal with it. And so, that's something that's been mandated by Department of Energy, the FAST Act, and so forth. So there are things being done.
When Jenny talked about the Pro-SWIFT Act, it has all these great things in it that we are all working hard on. It is an authorization act.
Yeah.
It is not an appropriation. So it didn't come with money. So I'm not a federal employee, so I can say that. Everybody else at this table would not be able to make that comment.
All right, we have 3 minutes left, and I'd like to hear from one more student. Row 5, the famous row 5, if we can get them a microphone.
Who has the lowest grade? We can help you out.
That was their hand the highest. No, I'm kidding.
So what specific lessons have we learned about how to make our space infrastructure and designing that space infrastructure to be more weather resilient?
So if we talk about, for instance, the satellite industry, the decades that we've flown satellites, we've learned that the susceptibilities to these energetic particles from the sun or in the magnetosphere, to electronics, to different subsystems of the satellites, and then that has helped the satellite industry build more resilient satellites. Frankly, it's particularly understanding where these satellites are going to fly, because there's areas that are going to be more susceptible to space weather or space weather effects than others. And so that's one example of what we've specifically learned, both understanding. But we've gained understanding of the science of space weather, and that's translated to technological advancements and change in a commercial industry, so that they can advance better.
Great. And right before we wrap it up, I'd like the 30-second pitch, Jenny or Tammy. How can our audience get involved?
Well, we certainly welcome everybody to listen in on our SWAG meetings, and we always have a public comment period. We really want to hear from people, what's on your mind. That's the one that comes to mind off the top of my head.
Yeah, and we also have the Space Weather Workshop. That's in April. Towards the end of April, there's a hybrid component, but it will be in Boulder, Colorado. And it's a great way to get everyone together and discussing these problems you heard, but in much more depth.
And there's a large student component to it.
There is.
Row
Yes.
5.
And we can use more students. Yes.
All right. Thank you, everyone. I think this concludes our time, so we'll get off the stage now. Thanks to our panelists.